Before you embark on your learning journey, it's a good idea to learn how you can navigate through the course interface and make the best use of the available features. When you access a module, you'll first view the landing page, which displays its title and the content structure. You can begin the module by clicking the Start Module button. This takes you to the first lesson. You can also view the content structure for each module in the left panel. Each module is divided into sections, and each section consists of lessons. You can also navigate to any lesson by clicking the lesson title in the menu. Note that you can go through the lessons in any order, and you can revisit them at any point. Keep in mind that to complete a lesson, you must scroll all the way down until you see the button that indicates the title of the next lesson. You can check your progress of the module at 2 levels. If you're looking for a specific topic, you can use the search feature. Videos are played using a custom smart player, which provides several features. The Captions button enables you to switch off or display the captions in one of the available languages. You can also customize the way captions are displayed by clicking on the caption settings. From here, you can increase or decrease the font size of the captions and even choose between different colors and transparency levels for the caption's text and background. If you prefer a faster or slower playback speed, you can change it in player settings. To navigate to other modules in the course, you click the Previous or Next buttons. You can also click the View Full Path button to view all of the modules available in the course. To complete a course, you must complete all of the modules that are marked Required. You're now ready to expand your learning horizons at UiPath Academy. Happy learning! Hello, and welcome to this demo on the UiPath Studio debugging interface. In this video, we will learn about running workflows in debug mode, catching errors, using the debug ribbon actions, and using the Locals panel. Now let's get started. First, let's take a look at the project that we'll use to showcase the debugging features. The workflow starts by reading employee data from an Excel file and enters the employee data into the form. This is what the data looks like. And this is the employee information form into which the robot will enter the data. Something's not quite right with this workflow. Let's run the project to see what happens. As you can see, we get a runtime execution error while entering the data into the form. The input string is not in the correct format. Clicking the Details button will provide more information. Let's click OK and see how we can use the debugging features to investigate the error. Let's start by having a look at the debugging menu. You can access the menu by clicking the Debug tab above the ribbon. We have quite a few options to help us identify and solve errors. Let's check them out. Clicking Open Logs will open the folder where the logs are locally stored. The Log Activities button lets you disable or enable displaying debugged activities as trace logs in the Output panel. Disabling log activities can be a way to send smaller log files to Orchestrator. The Highlight Elements button lets you disable or enable highlighting UI elements during debugging. Both the Highlight Elements and Log Activities options can only be toggled before debugging. Also, keep in mind that the settings for these options persist when reopening the automation project. The Slow Step button decreases the execution speed, letting you take a closer look at activities during debugging. When it's enabled, activities are highlighted in the debugging process. This action comes with 4 different speeds. Debugging with Slow Step at 1 times runs the workflow the slowest, whilst debugging with Slow Step at 4 times runs it the fastest. We'll click it twice to set the speed to 2 times, and we'll go back to the top level. Let's check our execution options. Clicking the Debug File drop-down menu under the Play button will open a drop-down menu. Now we can run the current file, debug the entire project, or run the entire project. Let's click the Debug option and quickly pause execution to have a look. Note that we've entered in the debug execution mode and we've clicked the Break button. Currently, the execution is in a paused state. From a paused state, clicking Continue will resume the execution, going through all the activities from top to bottom. Clicking Stop will terminate the execution and exit the debugging mode. By using Step Into, Step Over, and Step Out, we can execute activities one by one or in larger groups. We'll learn more about them later in this video. Let's click Continue and see what happens when the execution reaches the error in debug mode. Note that the activities currently being executed are highlighted in yellow in the Designer panel. The robot is entering the data into the fields. The UI elements it is interacting with are highlighted in red. And here it is. We've encountered the error, and it's thrown by an assign activity. When an error is thrown in debug mode, the execution is paused, and the activity throwing the error is highlighted in red in the Designer panel. You can see the error message displayed in the Output panel. The Output panel displays the output of the log message or write-line activities and exception messages, among other things. In our case, the error message reads, "Input string was not in a correct format." This implies that the data type of the variable and the assigned value might not match. Double-clicking it here will open the message in a separate window. You can also see it displayed in the Locals panel in the Exceptions section. Clicking the magnifying glass icon here will open the local value window with more details about the error. We'll learn more about the Locals panel in a few moments. Now that the error is thrown in debug mode and the execution is in a paused state, let's check what our options are for continuing. We can click Retry. This action re-executes the previous activity and throws the execution if it's encountered again. Clicking Ignore will bypass the exception and continue the execution from the next activity, so that you can continue debugging the rest of the workflow. Clicking Restart will re-execute the debugging process from the first activity of the project. Note that you can also use Step Out, Step Over, Step Into, Stop, and Continue, depending on how you plan to address the error. Let's take a moment to have a closer look at the Locals panel. The Locals panel is only available in debug mode, and it displays properties or activities and user-defined variables and arguments. As shown earlier, here we can find information about the thrown exception, but we can also see all the variables in our workflow and their current values. For example, the user's data table, the first name, last name, email, mobile phone number, city, state zip, and so on. Whenever a value changes during execution, we will see it in the Locals panel. Here, we can also see the properties of the previously executed activity and of the current one. In our case, the previous one was enter mobile phone number sequence, and the current one is the assign activity. One cool feature of the Locals panel is that we can modify the values for variables on the spot. Let's click the Edit icon for the first name variable. Let's change the name to Alex and click OK. If we were to run the workflow from this point on, the value of the first name variable would be Alex. When modifying variable values in the Locals panel, it's important to note that you can't change values for serialized data types, like data table rows. You'll notice that many properties that cannot be edited in the Locals panel display a magnifying glass icon on hover instead of a pencil. Next, let's check the data in the Excel file and see if we can fix it. We know that the exception was thrown when the assign activity tried to pass a mobile phone number. We also know that the error message is input string was not in a correct format. Finally, we know that it was in the first row, since the execution did not go past the first run-through for the for each activity. So, it's very likely that the first phone number is not in the correct format. And indeed, the first phone number contains a letter. Let's change it to 3. Save and close the file. Next, we want to check if this solves the issue. Let's go back to the top level and select the first sequence after the Enter Mobile Phone Number sequence. Enter city, state, zip. Let's click the Breakpoints button to toggle a breakpoint which will pause the execution there. Note that clicking the Breakpoints button again would disable the breakpoint, and clicking it a third time would remove it. We'll learn more about breakpoints later on in this course. Let's click Restart. OK, our workflow is running. Let's see what happens when it reaches the mobile phone number field. Great, it works. And since we've set up a breakpoint, the execution is paused before entering the Enter City, State, Zip sequence. Let's take this opportunity to check out what Step Into, Step Over, and Step Out do. Let's expand the current sequence. Note that it contains an assign activity and a type into activity. Step Into will debug the activities one at a time. This means that it will pause after every step. When you click this action, the debugger opens and highlights the activity before it is executed. Let's click it once. Note that it ran the assign activity. Let's click it again. It jumped onto the type into activity. And let's click it a third time. Now it's executing the type into activity. The keyboard shortcut for Step Into is F11. While Step Into executes the activities step by step, Step Over will not open the current container. When used, this action debugs the next activity, highlighting containers without opening them. This action is useful when you want to quickly go through large containers, which are unlikely to trigger any issues during execution. Let's have a look at the Enter Birthday container. Using Step Over will execute everything inside the container and will pause only after it exits the container. Let's click it once. We've jumped to the Enter Birthday sequence. Let's click it again. It executes everything inside the container and then pauses. The shortcut for Step Over is F10. Let's click it a few more times. We've reached the Enter Civil Status sequence. Let's click it again. Everything inside the container is executed. And last but not least, let's have a look at Step Out. Clicking Step Out will run the activities in the current container before pausing the debugging. In our case, it will execute the remaining activities until it reaches the body container. As you can see, it completed the run of the for each and paused before starting over with the next row. Step Out is available using the Shift plus F11 keyboard shortcut. Now that we've seen the features in action, let's remove the breakpoint and run the workflow in debug mode. The execution is completed successfully, and Studio exits debug mode. Note that the output logs that execution ended in 5 minutes and 52 seconds. This concludes our demo on the debugging interface. We encourage you to try out these features, and we hope that you have a great debugging experience. Thank you for watching. Hello and welcome to this demo on using breakpoints in UiPath Studio. In this video, we will learn about the various ways of toggling breakpoints, using the breakpoints panel, and creating conditional breakpoints, trace points, and conditional trace points. For this demo, we're using the same project as in the debugging interface video. A quick recap. Our workflow reads employee data from an Excel file with 5 entries, opens a browser window, navigates to a web form, and iterates through each row of the data table, entering the employee information into the form. Before we get into the details, let's start with a few definitions. Breakpoints are used to pause the debugging process on an activity which may cause execution issues. Note that a breakpoint will break the execution before running the activity or the container that holds it. Setting a condition or a hit count turns a simple breakpoint into a conditional breakpoint. Adding logging to a simple breakpoint turns it into a simple trace point, while adding logging to a conditional breakpoint turns it into a conditional trace point. Now, it's also useful to know that for trace points, you can disable pausing the execution and use them for logging purposes only while in debug mode. Let's see them in action. We'll run the workflow in debug mode and pause the execution. We want to add a simple breakpoint on the Enter First Name activity. First, let's select it. One way of toggling a breakpoint is to click the Breakpoints button in the ribbon, or to use the keyboard shortcut F9. Note that you can see the simple enabled breakpoint as a full red dot in the Designer panel, and you can find more details in the Breakpoints panel. Next, we want to toggle another breakpoint on the Enter Email sequence. Another way to do this is by right-clicking the activity and selecting Toggle Breakpoint option from the context menu. Clicking Toggle again will disable the breakpoint. Note the change in the icon when a breakpoint is disabled. Let's toggle another breakpoint on the Enter City, State, Zip sequence. Great! We've set all the breakpoints that we need for this demo. Let's have a look at the Breakpoints panel. It displays all the breakpoints in the current project, along with the file in which they are contained, conditions, and log messages. In the panel menu, we have the options of deleting a breakpoint, deleting all breakpoints, enabling all breakpoints, or disabling all breakpoints. Right-clicking a breakpoint will open a context menu. Here, we can delete the breakpoint. We can focus on it. Note that the focus in the Designer panel has changed from the Enter City State Zip activity to the Enter First Name activity. Let's do it again. Now the focus has changed to the Enter Email activity. We have the options of enabling or disabling the breakpoint here. Now we can also access breakpoint settings from here, but we'll talk about this a bit later. One last thing. Double-clicking a breakpoint will change the focus to that breakpoint. Now that we've set our breakpoints and we've explored the breakpoints panel, let's run the workflow in debug mode and see what happens. The workflow is executing, and we've just reached the first breakpoint. Note that the execution has entered a paused state and the sequence holding the breakpoint, Enter First Name, has not been executed. This is a good time to explore the various panels in the debugging interface to identify potential issues and test solutions. We'll click Continue. You'll see that the execution will continue past the disabled breakpoint on the Enter Email sequence and pause on the Enter City State Zip sequence. The robot is running the sequences and entering the data. Okay, it stopped before entering the city state zip value into the form. Alright, it's time to showcase the creation of a conditional breakpoint. You can also work with breakpoints outside of debug mode. We'll click Stop to exit debug mode and access the breakpoints panel in design mode. Let's enable all breakpoints. We can do that by clicking the breakpoint icon or clicking Enable All Breakpoints. Let's right-click on the Enter First Name breakpoint to bring up the context menu. We can access a breakpoint settings by clicking the Settings option in the context menu, or by clicking the gear icon to the right-hand side on the breakpoints row. Let's click Settings. The breakpoint settings window is displayed. Let's explore the fields. The Condition field lets you enter a Boolean expression. If the condition is met during debugging, the execution breaks and the activity is highlighted. The Hit Count field specifies the number of times the condition must be met before the execution breaks. The Log Message field specifies the message to be logged at trace level when the condition is met, or if no condition is set, when the execution reaches the trace point. If you enable the Continue Execution when logging checkbox, the execution will not be paused when the specified message is logged. It's available only if a log message was previously set. Trace points are useful to replace log message and write line activities used for debugging purposes. We want to turn this simple breakpoint into a conditional breakpoint. So, we'll add a condition and a hit count. In the Condition field, let's enter row of first name to string equals Greg. Let's enter 2 in the hit count field. This means that the second time the breakpoint is hit and the value of the first name variable is Greg, it will break the execution. Let's click OK. Notice that the icon has changed in the Designer panel and the Breakpoints panel, indicating that this is a conditional breakpoint. Let's select the second breakpoint and go to Settings. We want to configure it as a simple trace point. Let's add a message in the Log Message field. We have reached the email input sequence. This trace point will log the message when hit and will pause the execution. Let's click OK. Note what the simple trace point icon looks like. Next, we'll turn the last breakpoint into a conditional trace point. Let's access Settings. We'll add the condition row of city state zip to string contains Washington. We'll add a hit count of 2. For the message, let's add an expression. First name plus space plus last name plus is from Washington. We'll enable continue execution when logging. This means the second time when execution reaches the breakpoint and the city-state zip variable contains the substring Washington, the conditional trace point will log a message with the employee's full name, and the string is from Washington. But it will not break the execution. Okay, we're done with setting our conditional breakpoints and trace points. Let's run the workflow in debug mode and see them in action. Okay, it's running. Note that it did not pause before typing the first name, Greg, since the hit count is set to 2. It entered the last name and it paused before entering the email address. Let's check the trace point settings. The continue execution when logging checkbox is disabled, so the execution pauses whenever it reaches this activity. Note that you can see the logged message in the output panel. Let's enable checkbox. In the next iterations, the execution will log the message but will not pause on this activity. Let's click OK and continue. The workflow is resumed, entering the data into the fields. We've just started the second iteration. Now we're on the third one. The fourth iteration. And we've just started the fifth iteration. The first name for the fifth entry in our data table is Greg. This means the condition for the first breakpoint is met, so the execution has entered in a paused state. This is a good time to check the logs in the output panel. Note how the message "we have reached the email input sequence" has been logged for every iteration. Also note that the enter city state zip conditional trace point has been activated. For a quick reminder, the expression that we've used is first name plus last name is from Washington. Note that it has been logged in the output panel for the values in that data table row. Richard Dempsey is from Washington. The execution is paused on the enter first name activity on the fifth iteration. Let's check the condition. If we click continue, the execution will run to the end. Okay, the execution was completed successfully and we've returned to design mode. Note that you can see the output panel and the logs in this mode as well. This concludes our demo on simple breakpoints, conditional breakpoints, simple trace points, and conditional trace points. We encourage you to try them out, and we hope that you have a great debugging experience. Thank you for watching, and we'll see you next time. Hello, And welcome to this demo on using the Run from this activity and Run to this activity context menu options in UiPath Studio. This video shows how to access the actions from the activity context menu, run a workflow to a specific activity, and set values for variables at a specific point, and run a workflow from that point. For this demo, we will use two workflows to showcase each of the features. For the first example, we'll use the same project as in the debugging interface video. As a quick recap, the workflow reads employee data from an Excel file, opens a browser window, navigates to a web form, and iterates through each row of the data table, entering the employee information into the form. Let's get started. To access the Run to this activity and Run from this activity actions, we need to right-click an activity in the Designer panel and open the context menu. Let's do this now. Run to this activity will debug the project and stop before the selected activity is executed. This action helps you break down your workflow and check the first part. Run from this activity will start debugging from the selected activity. This action helps you skip over the first part of your workflow and set values for variables to debug the second part. In this example, we will demonstrate running to the Enter Last Name sequence. This means that all previous activities, starting with reading the Excel file and ending with the Enter First Name sequence, will be executed, and the robot will pause before entering the Enter Last Name sequence. Let's right-click on the sequence and select Run to this activity. The workflow is being executed. It's entering the first name, and it pauses before entering the last name. You can see this in the form as well. Back in the Designer panel, you can see the execution is paused on the sequence on which we've selected Run to this activity. Note that the sequence is highlighted. Now we have several options here. We can set breakpoints, use step into, step over or step out, or edit values in the locals, immediate, or watch panels to check how that will change the workflow's behavior. And this sums up how Run to this activity works. Let's stop the execution and open another project to demonstrate the Run from this activity action. The workflow asks the user to enter a value, adds 3 different amounts to that value, and types each one of the 3 results into a field of the WI application. We want to debug the workflow, starting from the first Type Into activity. To do this, let's select the Type Into Cache In activity. Right-click to open the context menu, and then select Run from this activity. Note that we've entered in the debug mode, and the execution is paused. We will use the Locals panel to change the value of our variable before starting to debug. Let's click the pencil icon. The local value window is displayed. Let's enter 200 and click OK. Note the message on top of the Designer panel. You may now edit variable values in the Locals panel. Press Continue when you're ready. We're ready to start debugging, so let's click Continue. You can see the execution has skipped the input dialog activity and it's jumped straight to the first Type Into activity. OK, it's done. Let's take a look at the data entered in our application. Remember, we've started with a value of 200. As you can see, the first Type Into activity added 50 and entered the result into the Cache In field. The second added 100 and entered the result into the On Us check field. And the third added 150 and entered the result into the Not On Us check field. For another example, let's run from the second Type Into activity and change the value of the input number variable to 500. Let's click Continue. Note that the execution started from the third activity in the workflow. OK, it's done. Let's double-check UI. We still have 250 in the Cache In field since we've skipped that Type Into activity. But now we have 600 in the On Us check field. and 650 in the Not On Us check field. And this concludes our demo on using the Run to This activity and Run from This activity actions. Feel free to give them a try and have a great debugging experience. Thanks for watching. Hello and welcome to this demo on using the test activity and create test bench actions in UiPath Studio. In this video, we will learn about testing individual activities in our workflows and creating test benches to check larger automation sequences. Let's start with the test activity action. This context menu option is used for running a test on the currently selected activity. Note that the test activity option is not available during debugging. To see how it works, let's copy the type into email activity and paste it at the end of the workflow. Let's re-indicate the correct field on the screen. We need to do this because the original activity used a partial selector, and since we've moved it from its container, we need to use a full selector. Next, let's right-click on the activity to open the context menu. We'll click the Test Activity option. Note that we have entered in debug mode. The execution is paused, and we are debugging this specific activity only. On top of the Designer panel, you can see the message "You may now edit variable values in the Locals panel." Press Continue when you're ready. Let's add a value for the email variable in the Locals panel. To do this, we'll hover over the Variables row and click the pencil icon. Let's enter the string mail@domain.com. We'll click OK. Now let's click Continue. And the activity has been executed. Let's open the form. As you can see, the robot entered the test string into the email address field. And this is how we use the test activity action. Now let's see how we can create a test bench. This action lets us create automation building blocks, which can then be tested and added to the final workflow. In this example, we want to create a test workflow that requests user input and enters it into Notepad. To create a test bench, let's go to the Activities panel. Right-click the activity that we want to get started with, in our case, an input dialog activity, and click Create Test Bench. Note that a separate workflow file has been created. However, it's not visible in the project panel. If we close this file without saving it, we will lose the test workflow. Let's fill in the title and label fields. Next, let's press Ctrl+K in the result field to create a new variable. We'll call it input text. Let's add a type into activity. Bring up Notepad. Click Indicate on screen, select the Notepad window, and enter the input text variable into the text field. OK, our test workflow is done. It's time to run it in debug mode. Keep in mind that our workflow contains 2 breakpoints. Let's click Debug File. We have reached the first breakpoint. Let's click Continue. And we've reached the input dialog activity. Let's enter Hello World. Click OK. It types the string into Notepad, and now we've reached the final breakpoint. When we click Continue again, it stops the execution. Keep in mind that the test bench is temporary. As mentioned earlier, if you close the tab without saving, you'll lose the workflow. To save the workflow, go to the Design tab above the ribbon menu and click Save. Save as, enter a name, and click Save. Let's go back to the project panel. Note that the workflow file is visible now. This means that it will still be available after closing the tab. This is how you use the Create Test Bench action. And this concludes our demo on using the test activity and Create Test Bench actions. Try them out. Have a great debugging experience. Thank you for watching. Hello and welcome to this demo on using the Watch panel in UiPath Studio. In this video, we will learn about adding values to the Watch panel, adding expressions, monitoring the values of variables and expressions during debugging, as well as removing entries. For this demo, we will use the same project as in the debugging interface video. As a quick recap, it reads employee data from an Excel file, opens a browser window, navigates to a web form, and iterates through each row of the data table to enter the employee information into the form. In order to be able to see the Watch panel, we need to run the workflow in debug mode. But first, let's set a breakpoint on the Enter First Name sequence, and then click Debug. And we'll let it run. Okay, it reached the breakpoint. Now on the left-hand side, you can see the Watch panel. It can be set to display the values of variables, arguments, and user-defined expressions that are in scope. These values are updated after each activity execution whilst debugging. As mentioned earlier, this panel is only visible in debug mode. Let's see how we can add variables to the Watch panel. For starters, we can add variables from the Locals panel. We'll hover over the first name variable, right-click, and select Add to Watch. Note that the variable's name, type, and value are displayed in the Watch panel. Another way is to add variables from the Variables or the Arguments panels. Let's open the Variables panel, right-click the last name variable, and select Add Watch. We can also add variables or expressions directly into the Watch panel. We'll click the empty cell in the expression column and add a simple concatenation. First name plus space plus last name. Let's add one last variable, email. All right, we're done with adding our variables and expressions to the Watch panel. As you can see, all variables are empty. Before we continue the execution in debug mode, it's important to know how the workflow assigns values to variables. Each sequence in the body of the For Each Row activity contains an assign activity and a type into activity. The assign activity adds a value from a data table cell to a variable. We will be monitoring the values of the variables in the Watch panel. Now let's get started. We'll click Step Over. Okay, it executed the Enter First Name sequence. Let's click Step Into. Note that the value Greg has been added into the form. In the Watch panel, we can see it assigned to the first name variable and as the first assigned element in our concatenation. Let's click Step Over again. It's entering the last name. Let's click Step Into. We can see the last name has been assigned to the variable. This is reflected in the expression as well. Great! Now it's useful to know that you can copy a value from the Watch panel by right-clicking in the Value cell. Let's click Step Over again. It's entering the email. Again, let's click Step Into. And as you can see, all the values for the watched variables have been assigned, including the email. One last thing about the watch panel. Aside from copying an entry, we can remove it by right-clicking in the expression cell and selecting Delete, or by clicking on a row in the watch panel and pressing the Delete key. This concludes our demo on monitoring variables, arguments, and expression values using the watch panel. Have a great debugging experience, and thanks for watching. Hello and welcome to this demo on using the immediate panel in UiPath Studio. More specifically, we will learn about using the immediate panel to check the values of variables, arguments, and expressions, as well as to assign values to variables at a certain point during debugging. For this demo, we will use the same project as in the previous debugging videos. As a quick recap, it reads employee data from an Excel file, opens a browser window, navigates to a web form, and iterates through each row of the data table to enter the employee information into the form. Just like the watch panel, the immediate panel is visible only when running the workflow in debug mode. We've already set a breakpoint on the enter city, state, zip sequence. Let's click Debug now. We'll let it run. Okay, it reached the breakpoint and the execution is now paused. You can see the immediate panel on the left-hand side. It can be used for inspecting data available at a certain point during debugging. It can evaluate variables, arguments or statements, and even assign values. To do so, you just need to type the variable, argument or expression in the immediate panel and press Enter. Let's add a variable to check its current value. We'll use first name. And as you can see, pressing the F key has brought up the IntelliPrompt window with some very useful suggestions, including the variable that we wanted to enter. If we click away and click back, we can see that it's not available anymore. Here's a useful tip. We can bring it back up by pressing Ctrl plus space. Okay, let's enter the variable and press Enter. The value Greg is displayed for the first name variable, the same as in the locals and the watch panels. Next, let's retrieve a value directly from our data table row. Let's enter the expression row of last name to string. Okay, we got the cell value Lucas. Let's try another expression. Let's say that we want to get the data type of a variable. We'll enter first name, get type. As you can see, we got the type of the variable. In this example, the string type. Besides checking values, in the immediate panel, we can also assign values to variables for debugging purposes. Let's say that we want to change the value of the first name variable to Alex. We'll just enter the expression first name equals Alex. As you can see, the value is displayed in the immediate panel, and it's also been changed in the locals panel, as well as in the watch panel. The immediate panel is not limited to short expressions. Let's try something a bit more complex, like a concatenation between several strings. Let's enter row of first name to string plus has the following phone number plus mobile number to string. Okay, we got the result. Greg has the following phone number and the phone number. Note that it returned the value Greg because we've referenced the data table cell and not the first name variable. For a few more things that you can do in the immediate panel, you can select data from the panel, right-click and copy it. You can delete entries by selecting them and pressing space, as you can see. And you can right-click anywhere in the panel's window and select Clear All to remove all entries. And this concludes our demo on using the immediate panel to inspect variable, argument, and expression values during debugging. Thank you for watching. Hello, and welcome to this demo on using the Call Stack panel in UiPath Studio. To be more specific, we will learn about how we can use the Call Stack panel to see the parent containers for the next activity to be executed. For this demo, we will use the same project as in the previous debugging videos. It reads employee data from an Excel file, opens a browser window, navigates to a web form, and iterates through each row of the data table to enter the employee information into the form. Just like for the watch and immediate panels, in order to be able to see the Call Stack panel, we need to run the workflow in debug mode. But first, let's toggle a breakpoint on the Enter Email sequence. Done. Let's start debugging. We'll let the robot run until it reaches the breakpoint. Okay, the workflow is in a paused state. You can see the Call Stack panel on the right-hand side. It displays the next activity to be executed and its parent containers when the project is paused in debugging. It gets populated after using step into, break, slow step, or after the execution was paused because an error or a breakpoint was encountered. Double-clicking a container in the Call Stack panel will focus on it. Let's double-click Sequence. Note that it focuses on the container. The same with Open Browser, Do. For each row, Body, and finally, the sequence holding the breakpoint, Enter Email. Let's expand the Enter Email sequence. We have two activities inside it. Let's click Step Into and jump to the Assign activity. Note that the Assign activity has been added to the Call Stack panel. Let's click Step Into again. Note that the first activity has changed from Assign to Type Into Email. Let's click Step Into once more. Now we're back on the Enter Email sequence. This is reflected in the Call Stack. Next, let's see what an exception looks like in the Call Stack panel. We'll click Continue. And we've reached a point where an exception has been thrown. As mentioned in the previous video, we can see the exception message in the Locals and Output panels. We can also see it in the Call Stack panel. It informs us that the exception was thrown by an Assign activity. And this concludes our demo on using the Call Stack panel. Have a great debugging experience, and until next time, happy automation!